Hello and welcome back to Math 8. This is a video over Section 5, and we're going to be talking about linear versus non-linear functions, okay? And we're going to take a look at the difference between the two and how we can identify those. So first, let's talk about what linear versus non-linear means. Linear means that the graph will be a line. So the graph is a line. Hence the word linear, where the root word is line, okay? Nonlinear means that the graph is a curve, all right? So the graph is curved, okay? And it's not a line, so not a line. All right, so the difference between the two. Now, when we have a linear graph, okay, so a linear graph, let's write this down, a linear graph has what we call a constant rate of change, all right? Constant rate of change. And when we talk about rate of change, that's a slope, okay? So the graph has a slope. A nonlinear graph, so a nonlinear graph does not have a constant rate of change, okay? Doesn't have a constant rate of change, okay? So in other words, we can say that the slope changes, okay? And we'll talk about that. We'll look at why that happens, all right? So that's the idea, all right? So we've done some of these things. We've talked about rise over run. We've talked about slope. And what we want to do is we want to find the rate of change given a table, okay? And so what we're going to do, and we did this in the last video, the rate of change is the change in one quantity with respect to another quantity, okay? So let's talk about that. Let's talk about this as I'm going to talk about this, I'm going to say the word slope out here, okay? And I want you to talk about slope is the same thing as rise over run, okay, which is the same thing as the change in y divided by the change in x. Okay, a couple of other things to remember. Remember that x is another word for input, okay? We also use the word domain, okay? Y is a term that we use for the word output, and we use the word range as well. Okay, so just so you know that we have those. All right, so what I want to do is talk about, the changes in this table. All right, so I want to see what's happening with my x values. And to go from one box to the next, what are we adding? Okay, what's happening? So here's what I've got. What I'm going to do is I'm going to add 1. To get from 2 to 3, I add 1. Actually, let me do this in red. So I add 1. Here I add 1, here I add 1. So my change in x, okay, change in input, or the x, is equal to positive 1, okay? Now the change in my output, my y values, so I'm going to put up here, this is my input, this is my output, okay? So the change in my output from 110 to 165 is plus 55. Okay, to get from 165 to 220, I'm going to be adding 55. To get from 220 to 275, I'm going to add 55. Now, one other way you could figure this out is to take, the previous one and subtract the other. So if I did 165 minus 110, that would give me 55. Okay, if I did 220 minus 165, that's going to give me 55. Same thing with 275 minus 220. That's going to give me 55. Okay, so and what I realize is because these are the same, all right, so when the changes are the same, when these changes in x and y are the same, okay, that leads us to a constant rate of change. Okay, that the change is constant, okay? So these numbers change at a constant by a constant number, so they're not changing, okay? So, and let's go over here that the change in the output is equal, and that's my y value, is equal to 55, okay? So we would say that our rate of change, ROC, okay, I often call this m, would just be equal to 55 divided by 1, which would then just give me a slope or a rate of change of 55, okay? And that's how we find that. So we did that in the last section, but I wanted to, kind of formally talk about it. All right, so linear function has a constant rate of change. A nonlinear function does not have a constant rate of change. So let's take a look at what's going on in this example here. Okay, so we can also look at rate of change from a graph, all right? And this scenario here shows the length and height traveled by a soccer ball, okay? And so in this example, in this graph, we're talking about the length that is traveled by the soccer ball. And then we're talking about time in seconds, okay? So what I know is that, our seconds, and I kind of look at the table as well. If we look at the seconds, to go from one box to the next, we're adding one each time, okay? And then the length that it's traveling in yards is traveling by 17 each time, okay? And so maybe it's easy for you guys to see this from the graph. But what I want you to see is that we have this rise here. This is a length of 17, okay? And then the run is a length of 1, okay? And we stair-step this. And it goes up by 17 each time, and then it moves over by 1 unit, okay? And we do that to get from one point to the next, okay? And that's where we're at, okay? So all these increase at the same rate, okay? So therefore, this is what we call a linear relationship. This is linear, okay? All right, now if we look at the height of the ball as time travels, so we know that the rate of change, before I do that, let's write that the rate of change up here, m, and that n is equal to 17 over 1. The change in my y is 17, the change in my x is 1, so we'll just write that my slope is 17. Okay, now if I look at this other table here, talking about the height, all right, what we know is that the time is increasing by 1 second each time, okay? But the height of my soccer ball is changing at a different rate. So the first one here, we're changing by plus 5.3. Okay, from 5.3 to 8, okay, that one's increasing by 2.7. Okay, now from 8 to 9.8, that's increasing by 1.8. And then all of a sudden, we start to go down. Okay, from 9.8 to 7.7, that's minus 2.1. So these numbers, okay, these numbers aren't the same. Okay, therefore, this is nonlinear. Okay, and we can check this by the graph. If we look at the stair step, okay, and all my x values are 1, but my y values change. Okay, and we can look at these from point to point and realize that the change in y's are changing by, a certain number, and not by what they should be, okay? So, I just want you to notice that here you have this stair step where the stairs are the same. Here, the stairs are not the same, okay? And so that's how I can tell that this nonlinear also doesn't form a line. It forms a parabola looking type thing. All right, let's take a look at the next page. Okay, so it says that there are 24 hours in one day. The total hours is a function of the days. Does the situation represent a linear or nonlinear function? So, what do you guys think? And I know that this is linear because it's a simple, my rate of change, and they tell us what it is or my slope is 24 hours in one day. So 24 hours per one day, okay? And I can just tell because that's going to be a constant rate of change. So let's think about it. After one day, you've accumulated 24 hours. 2 days, you've got 48 hours, okay? After 3 days, you've got 72 hours, okay? And after 4 days, 72 plus 24 is 96 hours. So as x increases, okay, so days is your x value, all right, hours is your y value. As x increases by 1, okay, your y values increase by 24. Okay? And I know that because they gave us this rate of change here in 24 hours in one day. So let's plot these points on a graph. So 124, all right, 248, okay, 372, 496, all right, and we get this linear relationship that shows that we have a line, okay? So this scenario represents a linear model, okay? And that's it, all right? So your ability to look at a graph or look at a table and distinguish whether you have a linear or non-linear relationship is part of what I need you to do. So you guys doing great. Go ahead and get started on the other work that is required, and we'll see you soon. Thanks a lot. Bye.